Now let's see the parameters of process. These are all the times which are important. So what is arrival time? So whenever any process gets into the ready queue, then that is what we call it as arrival time, which means that is the time at which it is ready to be executed, right? So arrival time, you can think of it like this: the time at which a process enters the ready state is called arrival time. That is also called as ready queue, because all the process are going to wait in the ready queue. And next one is burst time. Burst time means the amount of time that is required by a process, that is CPU time. Okay, you please make a note of it. I'll be just say dictating you the amount of time that is required by a process to finish, the amount of CPU time, right? So how much amount of CPU time should you dedicate to this process so that it could get finished? The problem is it would get completed, but the problem is before running a process, actually saying this time exactly is really very hard. So many of the problems are based on this burst time. Many of the scheduling methods are based on the burst time, but we cannot implement them in reality. The reason is we will not have anything called as burst time before we start it. Got it? So this is a bit confusing, because we are supposed to say the time required by a process before executing it, which means we are supposed to say how much time does it take to execute a process before even executing it. So it is tricky. And next one is completion time. Completion time is nothing but the time at which the process finishes, the process completes execution. It is going to arrive at some time and it is going to finish at some time. Then what is happening in the middle? It can be either with the CPU, which means it can be present in the running state. See this. Now the process is ready. The process has just entered this ready state, and now there is running state here, right? And then there is termination state here. Okay. Now between these two, which means the time taken by a process to the time at which the process arrives the termination state or the complete state, that finished state, is called completion time. Now if it is ready at this time at some point, and if it is come to finishing at some point, then what is happening in the middle? There are two things that will happen. One thing is it will spend a lot of time in the ready queue itself, right, in the ready state, or it will spend some time in the running state. How much time will it spend in the running state? That depends on the burst time, right? Therefore the entire time can be classified into two types, assuming that we are not involving any IO here. See, getting this IO time will complicate the things. So now the assumption is that a processor needs only the CPU time. Under that assumption we are going to see all the problems. Okay, so I am not going to consider anywhere that a process might need IO time. Without IO time I am just considering it. Okay, now without IO time means there is no way it is going to be blocked, right? So what happens now? It started at this point and it finished at this point. Then what happened in the meanwhile is, one thing is it will wait for the processor, that is called waiting time, and then it will execute it, that is called burst time, and then it will wait and then it will execute, right? So it need not happen all the time that for some time it waits, for some time it executes. That depends on the scheduling, which means is it preemptive or non-preemptive. I'm just taking a general case, which means a process might spend its time executing or it might spend its time waiting. Therefore the difference between the arrival time and the completion time is equal to two things, isn't it? Completion time minus arrival time. See, one more thing is completion time and arrival time are points in time, okay, and waiting time and burst time are durations in time, right? So when I take the difference between 2 points in time, then I get the duration, isn't it? So completion time minus arrival time, which means the time at which it arrived and the time at which it completed. Let us say the difference is 1 hour. Then what would that process have done in this 1 hour? It would have done two things. One is either it executes or it is waiting in the ready queue, assuming that there is no blocking state here, right? So under that assumption, under the assumption that we have only new, ready, running and termination, that is where we are doing it, to keep the thing simple. Okay, it is equal to burst time plus waiting time, right? So depending on which you can compute even the other times as well, right? Now Turnaround time. This is also called as turnaround time, which means the difference between the arrival time and completion time. The point at which a process has arrived initially and the point at which it completed. The difference is also called as turnaround time. Turnaround time, okay? And waiting time is nothing but out of this entire time, turnaround time, it has executed only for some time, right? And the remaining time it just waited for the CPU, that is called waiting time. So the relationship between waiting time, turnaround time and burst time is, you can say that waiting time equal to turnaround time minus burst time, which means if a process is in the system and it is not doing anything else, then obviously it is waiting, right? So waiting time is nothing but turnaround time minus burst time. It is either going to be in the burst time or in the waiting time. So if I take the difference between turnaround time and then burst time, I get the waiting time. Okay. And next one is response time. Response time is nothing but what is the first time at which the process hits the CPU, which means after it arrives, let us say it arrived here and then it waited in the queue, it is called waiting time, and after that some point it is given for the processor to get executed. See, when I write that it is burst time, it doesn't mean that the entire burst time is over. You might get confused here. Whenever I say that it is waiting time, burst time, waiting time, burst time, it doesn't mean that the entire burst time is over. I mean to say that it executed only for some time and again it came back into the ready queue so that it can execute later. In case if this entire burst time is over, why will it ever wait? It will directly go and terminate, isn't it? Okay. Now what I'm saying is, see, now a process has arrived here, let us say it is arrival time and this is waiting time for some time, not the entire waiting time, only for some duration, and then it has been taken up for processing at this point, right? So it is the first time a process is getting processed. A process is getting processed, which means that is the first time it will ever try to interact with the user. That is why it is called as response time. So what is the response time? So the first time at which a process gets scheduled minus arrival time, this is the response time. Got it? I'll show you with examples, it will be clear. Even if you don't understand anything right now, we are going to do hell a lot of problems and everything is going to be very, very clear once all the problems are over. Okay, so just go through this theory. I mean, don't stop watching, keep watching, everything will make sense by the end. Fine.